I'll share again. Let me share again. My entire
Yeah.
screen. You seeing my screen?
Yeah. Now
So these are the results we had got from the other analysis, eh?
yes.
So now, but still you're the one who has to do the calculation. You have to open TED.
Yeah, my text is already open.
It's already open. Then you share. Maybe just read for you these results, eh? Because they
I
are,
actually have them.
you have them, eh? So
Yeah.
you share so that we can go through it together and we see where it may not be okay.
You can see my screen.
Yeah, I can see your screen. So as usual, new and blah blah.
So we're gonna
Mm, columns or concrete? I think N.
concrete. So we got any can do, right?
I think, yeah. If they are on phase, we shall column design now. The good thing we are done with analysis. So you can go straight to column design. Then you calculate. So our column was which size?
It was 230 and 300.
230 by 300, eh? Yeah, so we know our column section. All we need to do is check whether it is passing against those rods and moments, yeah?
Yes.
So edit the length and the overall depth, overall width, yeah. So
Yeah. That-
mm, try putting T12 for bars, eh? Because already I'm seeing that 25. You try putting 12. If it doesn't give us what we want, we shall try the other one, eh?
Yeah.
Links, we have it as 8, okay, no problem. So you're seeing bars parallel to the z-axis. Yeah, they also
Yes.
did you put 3?
300. No, this one, the 3 was already there.
It was already there?
Yeah.
Design options.
So this bars parallel to the z-axis are these ones here, like these ones.
No, I think there are those in the middle. I think, yeah, there are those ones. The vertical ones, eh?
These ones,
The vertical,
the
yeah.
vertical ones. Oh, okay. Then the ones, the y-axis are these bottom.
Oh,
Okay,
yeah.
the ones, these ones here.
Yeah.
Design. Then have
You know our specifications. The ones we have been using: concrete class, minimum cover. Minimum cover is 35 is okay, or 40? No, we said we are using 1620.
we have been using 20.
We have been using 1620.
Oh. Mm. Then the reinforcement yield strength. That's okay.
Yeah, that's okay. Maybe
That's okay.
it is mainly common 500, but can use even 460, no problem.
Okay. Do I say okay?
Yeah, I think. So
Then we go to the detail.
check whether it is a cylinder column. You know cylinder column? A cylinder column fails in bending, yeah. Whereas
Yes.
a short column fails in crushing. And we always encourage you to have short columns instead of cylinder columns. Yeah.
Why?
Because you want your column to fail in crushing, and in most cases the crushing capacity is always high, because now you have concrete which is good in compression, yeah, reinforced with steel bars, yeah, so chances of it failing is very small. We design for cylinderness when we are trying to economize, and you're having you're trying to have the minimum size of the column somehow, depending.
Yeah.
So you see where you enter the designer road, axle road.
Yes. That's right. Then we have moment about the y-axis at the top, y-axis at the bottom, z-axis.
So our column was bending in one
This one have
direction.
to be.
Our column was bending in one direction. Remember when I raised one flame,
Yeah.
and according to our spans, this side had equal spans, 3 meters in one direction. So
Yes.
we assume that these moments in this direction are cancelling out because the spans are equal. So we considered one direction. So you will just have either y or z. But let me check here according to the drawing, according to whether it is x. We analyzed the direction in which we have the long side. So it is along the z. We shall only put results along the z. Along y they are cancelling out. So just put at the top along z you leave y you put 0 0. Or you can put the minimum.
I put the minimum.
No, just you can only put 0 0, but somewhere in the code there's where they give minimum moment.
Oh.
But since they are cancelling out, you can put 0 0 or you put something small like 10.
Okay, we'll do that. So I've put those.
Yeah.
Then we have the column is braced perpendicular to the y-axis. Column is braced perpendicular to the z-axis. Are these the 8 millimeter ones? Are they meaning those 8 millimeter rings?
The column slenderness. Hello, I didn't hear your question.
Like when they say the column is braced perpendicular to the y-axis, what does it mean?
When something is blessed, it means there is an additional like support.
Oh.
An additional support. Sometimes these things are done for earthquake design. Me, that's what I understand. Like in Japan, because of earthquake, they add some blessings. If you have seen some steel columns, we sometimes we bless them. Those like X form of reinforcement, like angle sections.
Oh, yeah.
Yeah, but I don't think there's any blessing. The only thing I know is here, the column is fixed at the top and also fixed at the bottom because it does not move. That's how it is analyzed. But there's no, I don't think there's any other more blessing. You try to untick. And it is, what are they saying up there? You read the other thing down? Up, you're seeing it?
Yeah, this will affect the effective length of backlink about the z-axis. A column is considered to be braced if it is assumed not to contribute to the overall horizontal stability of the structure. Note that a column may still be considered to be braced in a structure in which global second order effects must be considered, i.e. to a sensitive structure.
Now, the higher the structure, the more it becomes stress sensitive, and the more you have to consider those horizontal rods. You get?
Yeah.
A column is assumed not to contribute.
Yes, I do.
A column is considered to be blessed if it is assumed not to contribute to the overall horizontal stability. You can just uncheck. This.
Okay. Then the effective length backlink about y-axis.
This one, you first leave it unless they ask for it, because I want to be considered short unless they say it is necessary. Because sometimes they check and say you have to put in the buckling length.
Yeah.
Listen.
No.
What is it? Meeting out.
Oh, please enter a value.
Yeah?
Y-axis.
Yeah. Close. You try making them blessed. The other first ticks.
This is why I was having a problem what to
Yeah?
do.
You know.
This is why I was having a problem. I didn't know what.
I don't know. Let me try to check in Euro code 2,
Okay.
But I remember something like 0.8 error. Euro code 2. You're seeing my screen? You're seeing my screen? Hello?
Yes. Yes, I can see your screen.
Euro code 2. Somewhere it shows about the columns, The beams. You think like what they are talking about, Hello?
Yeah.
Are you seeing this is considered?
Yes, I can see.
This first option is considered unblessed. Are you seeing it? On the top, it is not fixed.
Yes.
Yeah. Whereas the one that is
Yes.
fixed on top is considered blessed. So our column, I think, is blessed, right? Because on top we have beams and on bottom we have beams, so
Yeah.
it is considered to be fixed all sides. Though these are in form of like a roller.
Yes.
They are in form of like hinges, but it is all considered blessed. Now the effective length when you are doing backwalling, now this has to do with the effective length. You'll check in Euro code 2, which close around around close 5.8. You're seeing it?
Yeah.
Slenderness and effective length of isolated members. So ours is from here, around here. Yeah? And in most cases it is this.
Yeah.
Or this. So they are telling you that L naught, which is the effective length, is equal to the total length divided by 2. Okay?
Yeah.
So our total length, what was our float flow? 3.2?
Yeah, 3.2. 3.2.
So 3.2 divided by 2.
1.6.
So we can enter that one. If you want to read more, you go to Eurocode, around close 5.8.
Yeah.
Eurocode 2. Did I share with you Eurocode 2?
You shared Eurocode 1.
I think I will also share with you this Eurocode.
Okay.
You can share again, you can share.
I'm still sharing.
You're still sharing, eh?
Yeah.
So you can go sharing.
You can stop sharing.
Yeah. So
Then I've put 1.6 and 1.6. I've put 1.6 and 1.6. So that's okay, right?
yeah.
Please input a positive value in millimeters for the effective length, the y-axis. Positive value?
I have a challenge. I'm not seeing your screen properly, but I will sort it out.
You're not seeing my screen?
I'm seeing it, but there's a way it is not zooming properly. But what is it saying? I'm not seeing that properly. I'm trying to sort it out. It is my problem, not yours.
Okay. So it's saying input a positive value in millimeters for the effective length for backlink about the y-axis.
Didn't you put in a positive value?
Yes, I put 1.6.
What? Meters, millimeter?
Yeah. So
No.
I don't know why it's telling me that.
No, this thing is in millimeter, and you put 11600.
Yes. Okay.
Meanwhile, let me log out and I log in again. My screen is disturbing me. Okay? Okay?
Yeah. Okay.
Vicent. Ewe. Baro engineer yandikire kachoferi nkai. Yandikire umeme. Engineer kanagenda kanazana mu just string uteri bataragisindikire.
Baragisindikire?
Hey.
Mwenje?
Mutaragisindikire. Are you share? Yeah, you continue sharing?
Huh? One.
I'm still sharing. You can see my screen.
No, I'm not seeing it. I'm not seeing it. Hello?
Okay, let me stop sharing and then I share again.
Ewe. Baruha. Yandikire umeme ari kubagira. Ngo they confirmed that Kachofi did work.
Baruha kari kuandika na wili.
Kajandika na wili ba? Bajitanka?
Aho bajitire uba bajipurintingira.
Can you see it?
I can see it. Now it's okay.
Wakano umecha mani munuga molisi. Yekamba zaze kurya lunch. Na utabitajwire na chaya uko ni ripoti yuri kwa na dikora kashesha.
So I put this and then I brought some temperature, what. Then ratio of
emirimu yo yatandika ekyamaanyi munonga certificate yanakentule twagikola yakaba primary school neyakamuce olwange
Akamuchera tinkabimanya byakamuchera.
tugenda kuzayo agokuba bakaba nitugambi
Hello?
wakireba
Hello.
Hello?
I was engaged in office here, but it's okay. So, where are we?
Yes, can you?
Where are we? Hello?
I put the effective. Can you hear me?
Yeah, I can hear you. It's okay. All these things are okay. So you're seeing some red something, eh? That's where the design gets interesting. When I see red, I know I'm working. But when I see green, I enjoy seeing red and I collect it than seeing green, eh?
Yeah.
But when you're already experienced, sometimes it becomes very easy. Sometimes you assume a member that is already sufficient and it's bars. You get it? That's why you can say an experienced engineer will come at site and say that that column you put less bars. This one is a small size. Add this one. Because from experience they know that the thing will pass. Eh?
Yeah.
So you see that they are showing us that the moment capacity is not sufficient. It is missing something small. Actual is at 2.95. Allowable is at 1.56. Eh? So by actual bedding utilization, it is also not okay. So you see, what can we do now? Engineer, what can we do?
Increase the geometry or the bus sizes.
I think I prefer increasing the bar size, because increasing the shape means I have to go back and I edit my drawing to put a bigger column. I go and change maybe the beam design. No. I prefer changing bars. Eh? So make it 16.
Make it like 16.
I think now it is passing, eh? But now I'm not confident with that 30 something, eh? Because there's a possibility when I want to make it, I would want to make these middle bars 12. Are you seeing those middle bars? Eh?
Yeah, these ones here.
Try putting 2 instead of 3. I've spent a long time without using this TEDs to use it to calculate a column actually. I normally finish everything in the plotter for columns. What is it responding?
Not yet, it's still loading.
Still loading, eh? Mugole. Charanga ojja kuba ayomba musajja takyamya waka.
There,
Akakopo ka chai akamala koma.
the bending utilization is one which is failing now.
I think I've seen what I wanted. Eh? It's as if this thing just provides one bar size. Eh? There's no option for changing bar size in the same section. Eh? Okay. So let's put back the 3 and we have our 60-16, which has no problem. So at this rate, I think it passes. Now when it shows that it is passing, I think it is okay to continue. To say okay, and we'll print our report. Then we'll go to the detailing part.
The minimum column dimension is established by resistance.
The minimum column dimensions.
The minimum
No, that has to
dimension
do.
specific established.
It has to do with the cover, eh?
Yeah.
Could you say okay? We shall increase the cover.
So should I don't know. Should we increase the cover?
That's what we shall do.
That
Because
was in
yeah, there are design options. Eh? Increase it to 40. Then you go on this exposure. I think it's okay. You did this. Those things were already entered, so I think it will be okay.
building utilizations by absorbing the
Back is a problem, eh?
yeah.
You reduce the other moments. You remove the other. You reduce the other moments were put on the y-axis, eh? Because remember we just assumed them, eh? You can now give it 5 because some of those small things may have something which is not economical, and yet we are trying to. Because that's the problem with package. You reminded me you activate your windows, eh?
Pardon?
You reminded me we activate your windows.
Okay.
I will send you something via WhatsApp, eh?
Okay. Yeah.
Is it okay now? So it's just playing with all those parameters.
You bring
You say okay, we'll go back and see. I want to really see what is inside there. You go back to the design options, eh? Because I have a feeling this section is enough. You come here on the fire resistance, eh? You reduce 30 minutes. Because you know what happens at the end of the day, they will plaster this column, eh? They will not leave it unplastered, so still it will. You have it to leave, but it's okay. Is it okay?
Okay.
Hope it doesn't refuse again.
Yeah, it's fine.
So you see, the more you want to be conservative, the more you forget about the economical, because the more you want to fulfill all those things, you have to provide a bigger section, yeah. And the purpose of VLOOKUP code is try to economize as much as possible. So you cross check down and see whether there's pass instead, because sometimes it can show fail. It may show you pass up there and yet down inside it is showing you fail. Is it okay?
It's okay.
Yeah, so you can close and look about the
It's
detailing.
fine. Seriously. But tell you, we're going to use AutoCAD, not some.
Yeah, you are supposed to look AutoCAD. I just wanted to show the aspects, the important aspects while detailing.
You're going to be sharing.
I'll be sharing something. Because now this is our column, 300 by 230. I already sketched it. So first of all, the section is very important, showing the bars physically that they are 6. With the bar mark,
Yeah.
this 0202 is a bar mark for the vertical bar,
Yeah.
which is this one here. So here you're showing that it is moving. You're seeing here there's some lap. Now for bar size 16, your lap should be at least 700. So 800 is okay to 1 meter. Yeah. So this is where the bars are lapping from on the ground. So this bar moves and goes all the way to the first floor. Are you seeing it? It goes and exceeds. You have to leave lap for the upper floor.
Yeah.
So then you can see it is 6016 bar mark 2. Okay. This one here shows that the bar is also, what is here is the same as what is here. But I didn't want to draw it because just to have the work look neat. Now we have links. I saw you with T8. Did it anyway show the spacing? Hello?
No, it didn't show us. It didn't show that. It didn't show spacing. Let me.
Maybe there's something we didn't try to internalize. The floor was flat floor.
Actually, didn't show that.
It did not show it. You try and do recalculate. We try and check where we can get where to have spacing. You try to recalculate.
So I'm here.
Wait. I think those are R8. That's why it should have showed it, eh?
Yeah.
You first go to design options. Okay. Wait. Go back to design options. There's something where I told you our column bends in one direction. There's something we forgot to check. It is unaxial bending. You're not biaxial.
Oh yes.
Yeah, I really don't know why you had. It is about the Z. Not Y, about Z. Yeah. Okay. So you realize that when you go into details, one side will disappear, eh? Yeah.
Yeah.
Okay. Is anyone they are showing shear? Scroll up, scroll slowly. Maximum. You're seeing it there? Go back on the sketch. Somewhere they are showing 16 number, 16 millimeter diameter longitudinal bars. Yeah. Maximum link spacing 230. Yeah. Generally 138 for 300 millimeter above and below the column, the slab stroke beam, and at laps. Okay. So that statement is very important. That below at the column there is a lot of shear, and when you check the diagram of shear, you realize that the maximum shear is where is at the start and at the top. Yeah. So some people, when they want to economize, they will have smaller link spacing towards the column, and at the end, then in the middle, they will have a what? They will have a bigger spacing, say 200. Yeah. So in that case, and sometimes it is hard to achieve on site unless you supervise and say, here you have it at 100, then here at 150, then here at 100. You get it? So having a smaller spacing, me, that's when sometimes I generalize and I just use like 150. Yeah. All through. I think you have seen the spacing, eh?
Yes, I have. Yeah.
Yeah. So for this case, they're seeing 138 for 300 millimeter below and above. So you can consider something around there, not exceeding 230. So some, if you want to take into consideration this 138, so you can still do it. Or you can even generalize and say all links at 125. No problem.
Yeah.
Me, though I sometimes I give 150. So that's what I wanted to check. So as I was still showing you, I had them at 150. So you can estimate this. You can estimate the distance between the beam and the ground. Then you divide by 150 and you get the number of them. So this is 19 T10 bar Mark 5 spacing 150. Okay.
Yeah.
We are here. We are here. Then you saw that you're having your section around here, and this is the detail of the section AA. So this you can do it for every floor. This is second floor. It changes the bar mark. This is third floor.
Yeah.
Yeah. And if you have a ring beam, you can indicate it like that. Sometimes if you're ending with a slab, it may be different. It is just mere drawing the way something is. Okay?
Yeah.
Then you show that it is a 200 by 300 reinforced concrete column, either 1 or 2 or 3. So me in this case it was C1. Okay? So any question about the column?
No, I'm okay.
Now the challenge with states, if you want to check per level, because you may have a column of like 10 floors. Yeah. So it means you may be forced to, if you don't want to provide uniform bars throughout, you may be forced to get the different moments at each level. You get it, and you design each section, each floor separately. If you want to economize, yeah. Yeah, it is not a rule of thumb that the bar size will be the same throughout. Sometimes you have like say 20 floors, yeah. So like from ground floor to around 5 floors, you may have a different section of bars. Then from there you change, depending on your maximum moments and the actual roads around there. Okay. So these bars could reduce actually, like when you come to the third floor where we have small axle load, could reduce from our frame analysis. If you still have it, I will show you that at this level, this was the actual load. At this level, at this node, this was the actual load. So you can pick those actual load and shears, and you design them separately. So, any question about the column design and analysis?
No. I'm understood.
You're okay with it, Now we could continue and also check out on the foundation. Since we are done from the column, we go to the foundation, right?
Yeah.
And in most cases, our actual loads, they don't change. Our actual loads don't change, though. The moments change for the base, because when the column has moments, even the base has moments. Now I'm challenged in most cases. I pick the loads from Prota. You can pick their actual loads and moments. Yeah. And I use the same, but still I can still use the same moments on the base. Because these same moments from the column, they will affect the base. Though if you're doing manual calculation, you get the actual load, you insert it on the base, on the pad, and the pad alone generates moments depending on the bearing capacity.
Yeah.
So what I'm trying to say, I have a visitor here. Let me attend to her just shortly. I'll get back to you. No, come on. Hello? Hello?
Yes, hello?
Yeah, I was saying.
Yes, hello. Yeah.
So what happens, for example, this is your column. You remember that analysis? I don't know whether you did it, of the base, eh? So this is your base. This is a column sitting on the base. Yeah. And now there's earth pressure. There's earth pressure. There's earth pressure down, which is what we can say,
Yeah.
what we call bearing capacity. You know, Newton said that action and reaction are equal but what? Are equal but what?
Opposite.
So don't think if you're sitting on the seat, you're saying the seat is feeling pain. The seat is also sitting on you. You get it?
Yeah.
So at the end of the day,
Yes.
you'll have your base subject to bend in this direction. Okay? Are you seeing it?
Yeah.
So now we have to design.
So,
When you apply this actual load and already there is something saying don't push me, this is soil here, okay, the base will be forced to bend in this direction. Now we designed for this bending, eh?
yes.
So if you're doing a manual calculation, according to the bearing capacity here and the actual load, you can actually get this moment, eh? But sometimes I use moments on the column, because if the column is also bending, say it is subject to bend like that, yeah, you're seeing, assuming this is the bending moment. So even this base has this base has to resist this moment in another way, okay? So literally there's a way this force is also affecting the what? The base. Do you still have the other column analysis, the other one we did? Do you still have it?
For the frame.
Yeah.
Yes, I do.
You try to open and I see if there were moments at the base, eh? At the start, at down. Because it was fixed, I remember. Are you opening it?
Yes, I am.
So as you're opening, I will be just taking you through just small, eh? So same applies with the base. You have to assume a size, then you check, yeah? So according to axle load, we shall start with the size of self 1.2 by 1.2 by 350, okay?
Yeah.
Then we apply the loads which came from the column and the moments. Then we check. If it doesn't pass, we increase on the size as we are checking punching shear, as we are checking bending capacity, okay? Then another thing you have to note that since bases are always exposed to earth, yeah, meaning we're expecting a lot of water, we normally give it a bigger cover, say 50 inch, 50 millimeter.
Yeah.
But now you can still go in Eurocode 2 at the start there and you try to calculate it and see how you can come up to 50. When the weather conditions are intense and the chemical reactions in that place are intense, you can even be forced to make it 75 or 100 cover for the base.
Yeah.
From my experience, I've realized most people on site, they don't give bases cover, and that's a big problem. There's poor workmanship and people just put 1 inch. They are just used 1 inch cover, yeah? Even some big projects, I was on one of the big projects in Arua. So these people are doing a culvert, box culvert. But their spacers were not standardized to achieve a cover of 50. Even on the way they were placing them on the ground, you'd find they are putting a spacer on an inner bar leaving the bottommost. An example is like here. Are you seeing these bars? Now this is the main bar. Are you seeing it?
Yes.
Now this is the secondary bar. This one here. Okay.
Yeah.
So if you put your spacer, you put your spacer on the secondary bar, that means the top bar here. Say it is 50 mm. Okay.
Yeah.
This is 50. I'm assuming this is my spacer. Do you realize that these bars will come a bit down compared to when you put your spacer on the bottom bar? You get it?
Yeah.
Now this spacer is very important because the lesser space you have, it means the more the environment will get in touch with this bar, and you know what happens to iron when it gets water. It is rusting.
Yeah.
So some structures are just sitting, we don't know what is happening. Anything can happen. In the case of a catastrophe, because surely you can't get a 5-story structure which is seated in a swamp, yeah? And you give it a cover of 1 inch and you expect it to last 200 years. Surely it is practically impossible. Did you open?
Yes, it does open.
So can you share?
You wanted to see the shear or the moment?
Actually, I'm interested in the moments because I'm seeing those are the beam.
Oh, sorry.
Are you seeing those supports down? Because here they are pins.
Yeah.
Now, I prefer to make them fixed so that I can see if there are some moments.
Yeah.
Let's go there and edit in the analysis. We try to edit them from pins. We make them like the other nodes. We see if we could get some moments acting on that base. Yes. TPC.
It's actually 3 and it's these ones, not so 3 and 6, not so.
Oh, boy. Don't make miracles. I'm seeing somewhere error. That one, you change that one. It was a bit like free. I don't remember. Was it free or like a node? I don't remember. You check from the upper one. You go back to 3. What is 3 saying? 3 is fixed in the X. It is also fixed in the Z. Then in the rotational. Is it free to rotate? If I check on the rotation and I see Hello? Hello? Hello?
Yes, hello?
Yeah, I'm checking at 3. 3 is fixed at the in the X and Z, but in you try checking in the rotation and we see. Fixed, yeah, make it fixed. I got 6, yeah, I got 6. So you got results? No, you got results. There's a result, see something.
Sorry, I don't. I'll go back.
No, wait.
Like my test closed. Oh, it's processed.
It's still processing it.
Yeah, it's still processing. I don't know.
It's a master processor. Did you receive the activator? Check your WhatsApp. I sent an activator.
Okay.
Hello, baby one. Hello, Machan. Bagame bakuletera mere? Bakuletera ki? Mangu tokalya bihimba. Bakuletera akanyama kasire? Bakuletera akanyama? Kayinja mugambire. Nzani wamanya. Hello? So what we can do, eh? Hello?
Yes.
These moments at the bottom of the column.
Yeah.
The terms we are going to use, for the base analysis, Okay?
Yes.
You're seeing 12.8 and 8.6, yeah? So we shall use these ones in the analysis. Though the base also needs in the X and Y, but we can provide in one direction since our base was our column was unactually stressed. So
Yeah.
it is 12.8. 12.8
Yeah, 12.8.
and 8.6. I think I can share. So you're seeing my word thingy?
Yes, I can see it.
Foundation, if you have the loads, it is easy. So we have moments. We call it Y. X moment. We had total point what?
12.8.
And the 9.8.6, eh?
8.6.
Now, this the base, eh? When you're entering the load, it normally wants them unfactored. Okay?
Yeah.
And remember, getting this 550.83 somewhere there has to be something like this: 1.35 GK plus 1.5 QK.
Yeah.
Now, this is a professional. You have to calculate the UDL alone and factored from the slab to the base. Same applies to the permanent load. Yeah. But in most cases, when I have this, they assume that 60% is this, okay, and 60% and 40% is this. So is it possible to get GK and QK from here? So I can try to.
Yes, it's possible.
Yeah, I can try to find a way of getting GK and QK from here. Even what can freeze. I don't know what's going on. Even my word is freezing. I've not seen this. I think Microsoft must be tracking me. You know, sometimes they affect these. There's a cracked program. Sometimes they make them not perform. Because there's no reason as to why my computer should be slow. It has happened to me even in Word, in Excel. They do it intentionally. Has it happened to you before?
Yeah, it has.
It really disturbs me. Eh? Word freezing. But meanwhile, you open TEDs. Eh? Let me leave these guys. We shall find a way. You share your screen and open TEDs. Eh?
So I had gotten GK and QK.
You had gotten them?
Yeah.
Okay, we shall use them. You open you share. You share and open. And start on the foundation analysis. Eh?
So I go to foundations.
Yeah, you go to foundations. Yeah. Foundation analysis and design. as usual.
Okay, so we have the length.
Yeah,
we-
you first assume 1.2.
$1.2 for where?
You first assume
1.2.
1.2, then the depth you can assume 350. Because this is like a zone I consider like minimum.
Okay, then permanent surcharge loads, variable surcharge loads. What are these?
Where are they? I'm not seeing them. Hey!
Down here.
Now there are cases. There are cases when you have surcharge load. Yeah.
Yeah.
Maybe on top of the
Yeah.
on top of the base there is soil. You get it? Okay. So when there's soil, it is like a permanent surcharge load. You have to calculate that weight. Okay.
Oh. Okay.
Yeah. So
Yeah.
assuming your base is 1.5 meter down and the base is 350 thick, blinding 400, so you have like 1 meter of soil. You can calculate that soil and its weight. Yeah. So for example, the square area there is 1.2 by 1.2 by 1 meter. Yeah. You want Vincent?
Yeah.
Vincent, eh? Hey, he went for lunch. He went for lunch.
Okay.
Yeah. So you can get one. It means 1.2 by 1.2 by 1 meter by 1.1 meter times the into what's the into weight of soil? The other one is just from class. What's the into weight of soil? But you see, you don't need to calculate this surcharge load for soil because are you seeing down up there soil details? Yeah, that one will calculate itself automatically. Okay? Just put 1.1 as the depth of soil on top.
Yeah.
Instead of 600, because now I'm assuming we're excavating 1.5 deep. Then our base is 350 plus blinding, which ends in 400, so the difference is like 1.1. So you can put like 1 meter or 1.1 for the depth of soil. It will calculate itself automatically. Then you go to soil parameters. Let me first call somebody here. Hello? Hello? Hello?
Yes, hello?
So now if you have done a geotechnical test,
Yes, hello.
if you have done a geotechnical test, that's why you determine these parameters.
Yeah.
Yeah?
Yeah.
If you have done this CP, you first untick the first option, calculate ultimate bearing pressure. If you have done DCP, you can enter the bearing capacity immediately. I think where there is 200.
Yeah.
So if you don't have, you can just assume. Me, if it is relative soil, I assume 200. If it is clear, I assume 150. Okay.
Yeah.
So I'm assuming this person is going to construct in relative soil. You'll call the architect, and the architect says the soil is good. But sometimes it is not good.
Yeah.
So these ones we shall just assume because we don't have geotechnical test results. But
Yeah.
in case you have the bearing capacity, you just change where you're seeing 200, you put the bearing capacity that was determined in the geotechnical report.
Yes.
So you can say, okay. So you have to add the column and the loads that you had estimated.
So we have the permanent load.
Yeah, no, you told me you had already divided it down. Hello? How much fish? Ati
What?
kulinka sitani bika sheru mukatwara yemere.
And then the variable.
Asheru numasakutwara yemere. Ato mwichiwanja yasera kashara kamwita. Jeshera arwash kwa Stanbic. Naende nyama, naende chitochi.
And
Naende
then these ones.
Asheru yenyini. Asheru. Enyama, chitochi, no mcheri. Mwenu wakuzaye? Kale, wena wiwaika wena nabaleba nakola shera. Yeah. Kale kan. Hello Barunji. Hello?
Yes.
So that's the load you got?
Yes, I can hear. Yeah.
Permanent movement in X, permanent movement. So we shall have movement in one direction. Our column was not usually bending.
Yeah.
The moments you remember them.
We shall have what?
We shall have moments in
Yeah.
Now you see the moment we have was general, yeah? You remember?
Yeah.
So you can also multiply by 0.6 so that you have the permanent and variable, okay? I remember we had around the 12.8, okay?
Wait. To get the permanent load, I did 0.6 times the axial load divided by the 1.35. That's correct, right?
That's it.
Okay.
Now,
So for the moment, the same
our
as
moment
well.
will be on the y-axis, So the permanent moment in y-axis I've multiplied by 0.6 and got 7.68.
7.1?
68. Then 0.4 multiplying by 0.4 I've got 5.12.
You put in 5 point what?
5.12. But now change the column details. I'm seeing length and width they are the same. You make the what you make. I'm seeing width I think is 230. Yeah. think we are okay. We are good to go. I think you can say okay. Oh, I think one thing was, I think it is vice versa. I think the way it is.
Yes.
I don't know. I think it's okay. Can leave it, no problem. Now, you're seeing that the applied base pressure is 344 and the allowable is 200, okay?
Yes.
This means our base is very small. It will fail in what? In the bearing capacity. Yeah? And the only solution for the soil to bear this load is when we increase the base size. Yeah?
Yeah.
So you can try changing it to 1.4 by 1.4 and you see. You increase it until when you see that the soil can be able to bear. Otherwise, when you leave it like this, it means after construction, your structure will have some settlement, okay?
Wait, I thought that our applied is this and then the allowed. Oh, so the applied has to be less than the allowed.
Yeah, applied has to be less than the allowable. Otherwise, your structure may sit down, may settle slowly. By the time you come back, the window is on the ground. So you may be forced to reduce it further to say 1.5, like until when it passes. Omuchino warayize omuchino waragirete nokwanole omwichina kananka ka kasero alga. So now it passes in the bearing. You consider even put a tick for you, eh? Okay?
Yeah.
So I think we can go next. We can go next and check the other parameters. Here I have no issue. So you know our concrete strength and what you can change those things, eh? The nominal cover to reinforcement, you can make it 50. So every time you see punching shear failure, yeah?
Yeah.
You have to have in mind thinking of that the depth of the base is not sufficient. Literally, the column can actually break through and pass through. That's punching shear failure. Okay? So the best solution for punching shear is always to increase on the what? On the thickness.
It's okay now.
Is it okay?
Yeah, I increased to 400.
You try checking in the x-axis. So if it is showing tick tick, I think you're good to go. You're having T12 at 175, T12 at 175, I think it is okay. Though, yeah, I think it is okay. It is okay, it can go with that. You can finish. But still, did you finish?
Yeah.
But remember, our column was not standing in the way I wanted it. You edit that one in your free time.
Pardon?
The column was not the way we wanted it. Because remember, we put our moments in the Y, and now we are making the column bigger in the X. Are you getting my point?
I'm trying to.
Like you see, it is 300. I see the sketch there. It is more wide in the width than in the depth. It should be vice versa, but it doesn't make a big change. Eh?
Okay.
You scroll down and check if there is pass, 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 pass. So if there is pass, pass, then you can save. That's how we do the base. Eh? Now,
Okay.
in cases where you have a double combined base, you have to get the loads for one column, the loads for another column, and you just add another column. There you added the other one. Eh?
Yeah.
Yeah, I think next time we shall try to wrap up for reinforced concrete structures in TEDs, as we try to see on our way forward. Eh? So literally at this level, you should be able to at least analyze and design a structure in TEDs. Because we started all the way from the slab, beam, column, staircase, now foundation, yeah?
Yes.
Yeah, at this moment you should be able to at least analyze and design as you're trying to gain more experience in what? In detailing.
Yeah.
So I think tomorrow we shall finish up with the detailing of the base, yeah?
Yeah.
And the detailing of those other things that we didn't touch. So that I share with you my file of detailing so that you can start practicing detailing. I want you to practice some good detailing before we go to Prota. Because Prota is just a summary of this. Eh?
Yeah.
With Prota, we shall build the whole house in Prota, then analyze at once.
Okay.
Though Prota doesn't give a detailed report like TEDs. Eh?
Yeah.
Any query?
No,
You alright?
Yeah, I'm alright.
Yeah. If you have no question, I think let's meet tomorrow. Are you working already?
Pardon?
Are you working already?
No, not yet.
But you're applying here and there.
Yeah, I'm trying to apply.
Yeah, you apply. Though you don't need to fix yourself. Eh?
I don't need to what?
I know we have different passions, but you don't need to specialize now.
Yeah.
Yeah,
I'm not yet even sure where.
Yeah, so where you get the opportunity, just go and try your level best. You learn on job. Eh?
Yes.
I think you have realized that things are not that different from what we studied, yeah?
No, they are not.
They are not different. In field, it is just, you find you're just conceptualizing on one thing and find it's what you have to do most times. Eh?
Yes.
Okay.
But I'll
Yeah?
apply. But I'm trying to apply.
Yeah, you try to apply. Yeah. Okay, next time say hi
Yeah,
to people that side. Eh?
later.